Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter nuclei. Okay, let's start the video. Question is, energy released when two deuterons 1s2 fuse to form a helium nucleus 2He4 is given. Binding energy per nucleon of deuteron is 1.1 mega electron volt and binding energy per nucleon of helium nucleus is given here 7 mega electron volt. Okay, so in the question they are telling energy released, that means definitely this is the exothermic reaction. How can we tell that? So for that I will write here the reaction, nuclear reaction, 1s2 plus 1s2. Okay, so when two deuterons will fuse, then what will happen that here this helium nucleus will form here plus some energy will release. Is it because which reaction? As I told you, exothermic reaction. So here you have to remember that two things. This Q value can be found by two ways. Okay, one way is there. To get the Q value we used to write like this here, delta M into C square. What is delta M? Mass of reactants minus mass of product into C square. This is called mass defect also. So when you will use this one, answer will come here in a joule. Okay, here I will use mass in a kilogram and C is speed of light 3 into 10 to the power 8 meter per second. Answer will come in joule. If in case I use one more like this, Q equal to delta M into 931.5 mega electron volt. In this what will happen that here this delta M have to use in a AMU. Okay, here I am using in a kilogram, answer will come in joule, and here I will use in a AMU, it will come mega electron volt. This is one way to solve this question. But if we see the question situation is there, you can see binding energy and all is given here. Okay, so for that we have to go in a second way. This Q value is given by, remember that here formula, binding energy of product minus binding energy of reactant. Okay, remember that here. This method we will use to get the solution of this question. And remember that here when the Q value is greater than 0, this is which reaction? This will be exothermic reaction, and if in case the Q value is coming less than 0, it will be which reaction? Endothermic reaction. Okay, so by seeing the question you can see very well energy released, that means what will happen that here you can see very well the Q value will come greater than 0, so only it will come here exothermic reaction. And which formula we will use here, 1 or 2? We have to use this formula because binding energy in the question they are telling, remember that here. Okay, so now we'll just see here. First we'll see binding energy of the product. So product, what is there? Helium is there, and reactant, what is there? Deuterons are there. Okay, so let's take here. So here I can write here this Q value or energy released is what here? Binding energy of product minus binding energy of reactant. Now, so for the product you know helium is there, so we can write here binding energy per nucleon of helium into number of nucleons we have to multiply, because in the question they have given binding energy per nucleon. So binding energy per nucleon into number of nucleons. So in a helium how many nucleons are there? You can see very well here the mass number is 4. Mass number is equal to the number of nucleons. Okay, so here we have to write here into 4 minus binding energy of a reactant. So here you can see two deuterons are there. First I will write here for the one deuteron, it will become here the binding energy per nucleon of the deuteron. We can write here 1s2 into 2. This is the binding energy of one deuteron, but here we have to multiply here with the 2. Why we have to multiply with the 2? Because here you can see here 1 and 2 deuteron nucleus is there. Okay, after that we can write here what is the binding energy per nucleon of the helium. Let me write here, this is the 2He4. Is it? So what is given here? Let's see here. You can see in a question this is given 7 and here it is given 1.1. Okay, so let me write here this is a 7 mega electron volt into 4 minus for the deuteron what is given here. See here 1.1 into 2. This is for the 1 deuteron, but here 2 deuterons are there, is it? So we have to multiply with 2 again. So this will come here 28 mega electron volt, and this will come how much here? 4 into 1.1. So it will become here 4.4. So when you will simplify this 28 minus 4.4, we can see very well it will come here 23.6 mega electron volts. Now you have to just see it. Can you see it? No? And here, which option is correct here? The correct option is here. Option C is the answer. Is it? So students, remember that here, whenever we have to get the Q value, by the use of mass defect, we have to write mass of reactant minus mass of product, and then we'll get here. But if we have to write with a binding energy formula, in the question binding energy per nucleon is given, then we have to do binding energy of the product minus binding energy of the reactant. When the Q positive, exothermic. When the Q is less than 0, endothermic reaction. Is it? So students, I hope so. This video is very clear to you. Keep studying, keep growing.